Hola, ¿qué tal? Nico?
Bueno, listo.
Bon.
Para aquellos...
J'ai dit, pas le bouton. Ça saute.
Perdón. Bueno, para los que nos... Atención. Para los que nos están escuchando, iniciamos la transmisión un poquito tarde debido a algunos inconvenientes con tormentas eléctricas que hemos tenido en la zona y no hemos tenido electricidad. Así que hoy lo que vamos a hacer es trabajar un poco con los datos que yo les voy a estar mandando por correo electrónico ahora a todo el grupo que está escuchando. Y bueno, los chicos que están acá van a trabajar acá y luego lo que vamos a hacer, hemos conseguido unos pedazos, digamos, de tronco y vamos a hacer la instalación acá, adentro, digamos, en el aula, porque afuera está lloviendo, digamos, y la verdad que se dificulta un poco la parte práctica. Así que, bueno, arrancamos y después hacemos una práctica de la instalación. Bueno, ahora sí.
So, bon dia. So yesterday we started to talk about these automatic dendrometers and looked at the ways to manipulate it. You know, I made some recommendations because I think that it's quite very important. And you have seen that there are different types of dendrometers that can be used. And also it's possible to build by yourself this kind of dendrometers. And
bueno, hoy vamos a ver esta parte que les adelantaba con algunas recomendaciones y él como les va a ir mostrando algunas partes, digamos, de cómo construir uno mismo un dendrómetro.
It's quite it's quite simple, you know. So you need this kind of data frame, which is quite rigid enough. And it's in aluminum so that you reduce this dilatation process. Okay, and then you have this kind of potentiometer. This small device here, and you know there's a needle, and when it's pushed, so the voltage is changing. Okay. So this is something that you fix like this on the with screws, but I don't have screws here. And this is the kind of screws that we are using to put in the trees. So you have this kind of. Okay, so that's quite easy. So with this kind of system here, so it's very convenient to move it because during the growing season you will have to move it along. And then connected to this potentiometer you have this data logger. This is one type of data logger that we are using when you want to have one dendrometer per tree and you don't have any other systems like Obo or Campbell.
¿Te acordás que eso es lo que dijimos ayer? Que yo les dije que había como diferentes formas de registrar los datos y este es la unión, digamos, al data logger que registra de uno solo.
Más o menos valores de eso, estamos en...
¿Cuál es de Prix?
70 euros.
70 euros.
this is 25. Well, it depends. If you buy it with a large amount, it's quite cheap.
Yes, but we can buy this kind of potentiometers here.
Yeah,
in
I guess so.
Argentina.
Yeah.
Nosotros podemos conseguir esos potenciómetros acá en Argentina. O sea, todas estas partes se pueden conseguir acá en Argentina. Lo único que es complicado es el registrador, no el registrador, ¿cómo se llama? El data logger. O sea, porque las marcas argentinas tenemos problemas de registro, o sea, no es por hablar mal, tenemos problemas de registro. Este es el data logger.
It's a kind of USB key. Yeah. Well, in the case where you have one tree here, one tree in the other side, so you don't need long cables.
O sea, completo así, costaría $250, $160.
No.
Wait. And then, so this is basically the system that you fix on the trees, and then you still need a battery, a 6-volt battery, to generate the current.
Claro, necesitas una batería para generar la corriente.
See, and altogether, it's about 130, 40 euros.
130, 140.
The battery, the data logger, and all the system. Yeah, about 130, 140 euros now. Yeah.
Pero me parece que lo importante es que lo podés armar con cosas caseras, digamos. Esos potenciómetros nosotros los compramos en Buenos Aires. Entonces es más fácil.
And so this is, you can also program it for 10 minutes or 1 hour or whatsoever. It's easy, and then you plug in and you have a special software to read it.
Claro, dice que eso es lo que tiene o sea, que tiene la ventaja de poder programarlo y que después lo enchufas a la computadora porque es por USB. Entonces es directo, es simple. Y sobre todo cuando uno tiene un árbol aquí, otro árbol muy lejos, no sé, me imagino en un ensayo de manejo, por ejemplo, que son ensayos muy grandes, puede ser útil trabajar con esto.
What I said also yesterday, it's because at the beginning we started to use it just like that, with a battery on the trees. It's a bit sensitive to rain, so you need to protect it against rain. So usually we put a plastic bottle.
Normalmente le pone una botella de plástico y también ayer él mostró una caja de plástico.
Sí, where you put all these sensitive things in it.
Todas esas cosas sensitivas, digamos, las pone dentro de un tupper, una cosa así.
Okay, so now to come back to the presentation, I just want to show you first how the signal that we get out of a dendrometer looks like.
Claro, cómo se muestra la señal, o sea, los datos, cómo se ven.
So this is an example with larch in France, so it's in temperate climate, and you can easily recognize, you know, this is 2016, which is represented somewhere here, and then you'll get again another year with 2017, and then you have part of 2018 starting. So you see clearly that, well, there's nothing happening during winter, or nearly nothing, just small variations. Then when you arrive again in the other winter, the same, it's very flat. And again in this case. And you just have this variation here during the growing season.
Esa variación que ustedes pueden ver ahí es la variación que se da durante la sesión de crecimiento.
So this is quite easy when you're dealing with species with clear annual rings.
Eso es claro cuando uno tiene especies que marcan anillos anuales.
So this is another situation in another country. This is eucalypts in Australia. So no, radial.
Radial.
Radial, sí. Sí. It's a situation that you can meet in climate like this, in subtropical or tropical climates. Use eucalyptus in Australia, where you do see that, I cannot read, but it's 2095 and it goes to June 99. So you see you have nearly 4 years, which are represented here, and you don't see anymore this flat period corresponding to winter. So typically in this case, and this is what you can read in one of his papers of Drew and Downs, you have to combine techniques. And typically it's the same here in...
Dice que tenemos que combinar técnicas, porque cuando no están bien definidas los anillos de crecimiento, él, bueno, puso ese ejemplo de eucaliptus y el otro ejemplo de otro paper, donde hay especies que no es fácil definir el periodo de crecimiento, necesitamos combinar técnicas.
So the solution that they found in this situation is to combine that with anatomical observations. And you see that from time to time you can observe your small plateaus, which means that there has been some short period of slower growth, and which they can connect with, I think it's a density of vessels of something like that. And so they were able to reconstruct according to what they were observing on the increment course, for example, about these growing seasons, or so-called growing seasons.
Dice que, o sea, en ese caso ellos combinaron con técnicas anatómicas para poder identificar en esos pequeños platós que se dan, esos pequeños achatamientos, digamos, que se dan, los relacionaron con los vasos. Entonces pudieron establecer, digamos, mejores límites del periodo de crecimiento.
Yes, and so it's what I'm recommending to Maria Elena, probably with the dendromatous which were established in San Gabriel. It's probably to use a pinning method, at least to mark the cambium at, let's say, at the beginning of winter, or just to know when is the beginning of winter. When you look back to the profile, so you can, according to the position, knows exactly on your dendromator profile where you are standing.
Claro, dice que él, bueno, era eso que estamos discutiendo por estos días, que él me está aconsejando es que los dendrómetros que tenemos montados, o 25 dendrómetros de San Gabriel, al principio del invierno nuestro, que nosotros decimos, bueno, junio o julio, le ponga una aguja y active el cambio para marcar por lo menos una fecha determinada en el perfil, en el perfil del dendrómetro. Porque como yo ahí puedo establecer una distancia, entonces por lo menos para datar un punto y tener algún punto de referencia. Porque eso es lo que evidentemente no tenemos mucho, es cuando el árbol paró por el clima, teóricamente.
I think we saw yesterday that with Pinus elioti, that's quite clear. The delimitation between the rings is quite clear. When you move to Caribea and even the hybrids, it seems much more complicated. And from the slides that we saw yesterday, I'm not convinced that really we pick up the right...
Él está convencido de nuestra delimitación de anillos.
Yeah. Okay.
Bueno, tengo que ser sincera.
So we saw in temperate climates, so that really, and we saw already yesterday with the experiment that I show you, that when we are at the inflection point here, this is the starting of a cambiar activity. So up, and so that's quite easy. And to connect it with vegetative flushing or something like that. So that's quite nicely synchronated. Now, if we move to another kind of climate, like the boreal climate, this is typically an example from Quebec, and this is how it looks like. It's a growing season here, which is represented from November to November. And you see that the signal is decreasing. Yes. The temperature is so cold that the trunk is shrinking, so that the trunk is, the signal is decreasing, and then the water starts again to fill the trunk. So this is what you're observing here, the radiation period, and then it starts to grow. Yeah. So you see again, like in the tropical or subtropical climate, it's very difficult to know exactly from this kind of signal when growth is starting. So that's why you should keep in mind that among the different techniques that we told you, probably we need to combine them. So that's not one unique method that is the right one, but you need, in certain cases, to mix them. Okay? So this is typically the yearly or seasonal pattern, and now when you move to a daily pattern, again, so you have seen the yearly pattern for 2017-18, and then if we make a focus, for example, in one of a period, so this is typically what you will observe, a daily cycle, which is represented here, where you see that you get the maximum of water content and maximum development of a trunk, which will arrive during midday, at mid-morning. And then when the tree starts to transpirate, so there will be a contraction, which is with depletion of the water, basically during the afternoon. And then it will start to expand again up the next cycle. This is a day. This is one day and another day.
Is the cyclone, is the limit of cyclone?
No, this and this.
No.
This.
Blue. Yes.
Look at the. Well. No, a cycle goes from there to there. No, it can be one day, or it can be sometimes more than one day. Sí.
Deshidratación.
No? So 13 heures, 14 heures, it depends on the season, but yeah. Here it's around. Yeah, because it depends. So basically, we can describe a cycle with 3 phases. So there's the contraction phases, where the tree is shrinking. Then you have the expansion part. And then you have the part which is called the increment. Okay? Sí.
termómetro registra el movimiento, digamos. Lo que esa parte es como la interpretación que nosotros hacemos desde el punto de vista fisiológico de lo que pasa en el árbol para solamente anular el crecimiento, te diría. Claro, y después lo comienzan a dividirse las semillas. O sea, que no hay que estar todo el tiempo creciendo. Claro, claro, porque el árbol sigue viviendo. Ayer decíamos que hay muchos procesos que se dan simultáneamente. Entonces, el árbol tiene una dinámica, digamos, hidráulica que nosotros con los dendrómetros la estamos detectando, que no es crecimiento precisamente, es simplemente una dinámica diaria del árbol, hidráulica del árbol, digamos, del funcionamiento del árbol, y eso no es crecimiento. Entonces, lo que Luz quiere dejar súper claro es que el crecimiento son los últimos 4 puntos. Es lo que supera el máximo del anterior, digamos.
Well,
Okay.
again, yeah.
It's clear now.
Yeah, no, but it's not so clear in fact, because, no, because you should remember that these dendrometers are put on the trunk, on the bark.
Está puesto sobre el tronco, sobre la corteza.
Even if you remove a bit of retidome, you're still on the bark.
Claro,
That means,
que saques el retidoma, estás en la corteza todavía.
so that means you include part of the bark, you have the phloem, you have the cambium, and then the xylem. So,
Tenés el cambio, tenés la corteza, tenés el floema, el cambio y recién el xilema, que es lo que vos querés registrar. Entonces, dice que tampoco es tan claro, o sea, hay otros ruidos más.
so you are recording here the whole movement or all these different tissues.
Ese movimiento es el registro de muchos tejidos, en realidad.
So, but you might remember yesterday that I showed you a dendrometer with 2 pins.
¿Se acuerdan que ayer él nos mostró un dendrómetro que tenía 2 agujas?
So this was designed by Swiss colleagues, and the idea is to have one as the one we put normally on the bark,
Sí.
and the other pin goes up to the xylem.
Y el otro pin, una aguja sobre la corteza y la otra... Claro, with 2 potentiometers.
Yeah.
Sí, con 2 potenciómetros. Entonces, una que vaya al xilema y la otra en la corteza.
So that allows you
Dice que fue el
to,
diseño por los suizos.
yeah, to relate, you know, the movement really connected to the xylem and the one connected to the whole thing. But the price is double, so it's
Pero el precio es doble.
no. Just to sum up.
Sorry, Luc, but with 2 pins, you how to preserve the tissue, or this is an operative question.
No, but
how to preserve the xylem?
no, but I think the idea behind is more physical, because again, you say the bark physically, when you put water on the bark, it will swell.
Yeah.
If you dry it, it will shrink.
Yeah.
The same for the xylem, it's wood, and if you put it in water, so it will inflate. If you remove water, it will deflate. It's not biological, I should say, it's more physical measurements. Of
Es más una medición física, porque yo le preguntaba cómo haces para
Because
llegar
it's-
hasta el xilema, o sea, operativamente.
yeah, otherwise you have a cambium which is nuded and it cannot survive. So
Claro,
yeah,
si
yeah.
llegás, es como que llegás más cerca, pero no necesariamente al sistema, digamos. No se muere.
So just maybe if you have this in mind, that this pin is recording all things occurring along the radius, so we can divide the stem radial variation in 2 parts, one which is reversible and one which is not reversible.
La variación del cambio del tronco lo podemos dividir en una parte que es irreversible y una parte que es reversible.
So the first thing is this shrinkage and swelling that we observed due to the bark, and 90% of this shrinkage and swelling is going on in the phloem. Yeah, so we usually consider that the xylem plays maybe less than 10% of this swelling and expansion. Okay, so this defines these two phases of expansion and shrinkage. Then you have a part which is not reversible, which is due to cell division and cell elongation. And as we said, this concerns both the xylem but also the phloem. And this will define the radial growth, what we call the radial growth. But part of it is also the phloem. It's narrow, it's not much, but it's part of it. And if you want to go a bit further, so some authors like Grisar in Slovenia could prove that there are some catabolic processes in the bark which makes also some reduction of radial growth. But again, it's very minor things. And then, in the same way as you have 90% here for the phloem, you have this 10% coming from the xylem, shrinkage and swelling, okay? Which also contributes to the expansion and shrinkage. So what we should consider now is this is, let's say, the kind of signal that you have along the time. And the question is now how to disentangle the growth and the water movement. So it's a bit what we show. If you take exactly the same picture here, so in red, this is what we will be considering as the growth increment, which goes from one peak to another one. But for example, you see here that this peak is lower than that one, and so on. So there's no growth. Basically, there's no growth. Okay, and to find back again growth, you draw the line here, and you will find this part. This is one way to do. It's well, in some paper you can read. It's what they call the zero growth. That means it's zero growth when you have these contraction phases, which can last during many days sometimes. In dry climates, during many days you have this retraction and no growth. So you have here the signal which is separated with in red the growth and in blue which corresponds to this water movement. So the question is where this, when we looked at this water movement in the tree, so you have to remember that, well, a tree you have roots, you have a trunk, and you have the crown. So transpiration creates a water potential gradient within the trunk and sucks the water in the ground. And this is okay until, you know, the soil is able to provide water to the tree.
Claro, dice que, bueno, ahí lo está planteando desde el proceso de transpiración que genera una diferencia exponencial desde el agua que ingresa por las raíces hasta que, bueno, se va transmitiendo. ¿Sí?
Si se podría inferir al estudiar esa variación con el consumo de agua, ¿hay algún estudio que...?
No sé si en francés o en français. Lui, il demande si il y a déjà des études sur les mouvements de l'eau dans l'arbre.
Oui, oui.
Y si il y a déjà quantifié la quantité de l'eau, la consommation. Sí,
Sí.
ellos tienen ya mediciones hechas. Nosotros algo que está de consumo de agua tampoco algo, ¿no? Sí. ¿Algo que
Sí, yo sé que
O sea, me parece que la combinación con el dendrómetro te va a dar lo que él está diciendo. O sea, si la contracción es por el agua, movimiento interno o externo.
sí, o sea, que estaría bueno
Que hay como movimiento interno, digamos, y después que eso te va a registrar, digamos, el aparato que te pide el consumo de agua.
Claro.
O sea, cuando no hay movimiento, no detecta el aparato suponente movimiento que fluye a través del árbol, se me hace como que el dendrómetro no sé si va a haber una contracción del árbol, digamos, mientras esté en movimiento. O sea, porque lo que te registra, lo que te mide el consumo de agua es bastante parecido a lo que te registra el dendrómetro, digamos.
Sí.
Solo que el de consumo de agua no te registra la contracción, digamos. O sea, o hay movimiento cero. Pasa, pero el dendrómetro lo que te va a decir es cuenta cero, cierra las tomas, no hay movimiento de agua, pero lo que te registra el dendrómetro sí se va a ver. Si no hay contracciones, porque directamente no hay ni radial ni longitudinal.
Claro, sí. Ils sont en train de discuter sur le mouvement de l'eau. L'avantage du dendromètre, c'est l'enregistrement de tout ce qui se passe. Parce que les capteurs de flux, ça te détecte si
Oui, s'il
il
y a flux ou pas.
mouvement
Oui.
ou pas.
Oui.
C'est ça.
Oui.
Ok.
Okay, so you see that most of the water, of course, is coming from the ground and sucked to the crown where it's evaporated. But in some period of short water deficit, so the water can also come from the bark and feed up, you know, the tissue.
Bueno, que el movimiento de agua, o sea, ese movimiento se condice con un llenado y vaciado, digamos, de los tejidos.
So, as you know, most of the water is concentrated in the needles of a crown or in the leaves. And well, in some of our species, we consider that nearly 8 times more water in the leaves and the needles than in the trunk, basically. And then you have some in the wood, and some of the water can be in the xylem of the sapwood. But you see that this water will only be available to the tree when the water potential, which is negative as you know, exceeds the strength of the cohesion among the water molecules.
Sorry, you can repeat, please?
Because this water is only available if the water potential exceeds the strength of the cohesion among the water molecules. And if you go behind, so the plant becomes in danger because you are starting to get cavitation, and usually we consider that there's a threshold somewhere around minus 2.5 megapascal.
Si el potencial negativo excede, digamos, un determinado punto,
So you're starting to get behind this threshold embolism, cavitation, and so the.
Eso lo que hace es dañar los sectores por los cuales el árbol transmite, o sea, transporta agua, conduce agua.
And so behind the xylem, you have also water in the lumina of inactive xylem elements, which is of course available, and also in all this intercellular space.
Claro, él está describiendo los diferentes tipos de agua que podemos encontrar, digamos, dentro del tronco, por decirlo de alguna manera. El anterior era el agua en la luna, digamos, del xilema. Este, luna, no sé qué es, pero es en las partes inactivas en los elementos inactivos del xilema y en los espacios intercelulares. Hay agua también ahí.
So it's a water which is quite easily released, and you know when you're at high water potential, this is water is really.
Con un alto potencial es fácilmente liberado.
And you see that this capillarity water content is reversible, so it can go out and go in. So, and then finally you have this water is also in the living cells from the bark. So that you will find in different tissues of the bark, in the phloem, in the cambium, and in the parenchyma, and also in the wood rays. And again, it's water which is quite easily accessible and reversible, the flow.
Hay agua fácilmente accesible y es un proceso que también es reversible. Esto en realidad es para dar una idea de cómo se explica ese movimiento de agua que se produce en el árbol, ¿verdad? Por eso es que está hablando de los tipos de agua que encontrás. No los tipos de agua, sino dónde encontrás agua. La disponibilidad.
So, and on this slide, this is an experiment which was conducted by a Swiss colleague, Zweifel, which shows you part of a xylem. Here you have a cambium, you have the phloem, and then you have the bark. And you let it dry, and you see that this is before, when it was saturated with water, and then when water is removed. So you will see that the tissue which are more affected are not the xylem at all, which is not moving, which is nearly not moving, but it's mostly the bark which is shrinking. So mostly the phloem, which is contracting. Yeah? Yeah. Yeah. And in the same experiment, so they follow up the way wait a minute. They looked at the volume and the weight of the water which is removed. And you can see that as far as this water potential is less than -2, you have mostly a linear relationship. So the ratio of the weight loss and the volume reduction is equal to 1. And that means that this water is mostly coming from the bark. But then, when the water potential decreased even more, you see that you are passing in a non-linear situations for this ratio, and in that case, you are starting to deplete water in the xylem.
Okay. Oh, it's not easy.
No.
Cuando le aplicaron, digamos, un potencial hasta 2, el agua es como que no hubo tanto cambio en el volumen. potential.
Yeah. So what we can also consider is that this change of dimension of phloem basically is a way to measure the quantity of water which is removed from the bank. It allows you to have a kind of proxy of the quantity of water. Which is, see, in these studies they were working with young Norway spruce, and they were considered that this water content removed from the bark and exchange with the bark represents about 2 to 15% of the water transpired per day. Sí. Yeah, sí.
Depletion of ceiling.
Because what? Sí. Yeah.
Ahí comienza el vaciamiento del xilema. Lo que, que era esto que decíamos, que hasta el 2, hasta el potencial de 2, saca de la corteza y del floema.
So you see, you start to deplete water in the bark. And then when the water potential becomes too much negative, so we are starting to go. And then you reach a critical stage where you might get embolism. So.
This paper or this study did it in a dry condition, in sequía, in condition of
well, it was a right. Yeah. It was a very special experiment in the sense that they used young trees. They were 6 years old, if I remember, and then. They cut portions of a trunk, and then they let them dry. Yeah. And follow up what's going on in terms of water potential, elimination of water, and so on. Yeah. Yeah. Yeah.
No en árboles en pie.
Yeah. No, because you see that the precision that you need to follow up this movement of water is very tiny, and you need something to do in the lab.
Claro, dice que necesitas como la precisión que necesitas en la medición, en ese tipo de mediciones. Todo el resto, claro, necesitas mucha precisión, entonces normalmente por eso usan solo un pedazo del tronco para poder detectar esos cambios, si no es imposible llegar a esa conclusión.
Porque lo deben de conectar y ahí...
Sí, eso es lo que dijo. Claro. Es para sacar todos los otros efectos.
O sea, una vez que se elimina todo lo que es del problema,
recién comienza a eliminarse del xilema. Es para saber la dinámica, digamos, que tiene
que no todas las especies tienen este comportamiento, ¿verdad?
Yes, she said that not all the species have the same performance or the same...
Probably there might be differences, yeah.
Yes.
Yeah.
Dice que sí, hay probablemente hay muchas diferencias.
But the idea was really to prove that water is coming from the bark, and water can be useful, you know, to manage some critical period when you have water shortage. So this water in the bark is able to move from the bark to the living tissues to maintain the activity.
Claro, esos tipos de puede, o sea, el agua que está en el floema pasar al xilema y ir compensando, es parte de la compensación que hace el árbol diariamente. O sea, esos estudios contribuyen bueno, a ese tipo de cosas, a estudiar ese tipo de...
And he wanted to prove that most of this radial changes due to water is in the phloem and not in the xylem.
Claro, y ellos querían probar que los cambios eran básicamente en el floema y no en el xilema, esos movimientos de agua. Bueno.
So this is just to sum up maybe this. So you see that the foliage basically contribute much to daily transpiration because much of the water is there indeed.
Claro, dice que bueno, en la copa contribuye mucho más a la
And so the water, the water which is released from the bark, it's a kind of buffer.
el agua que sale de la corteza es una especie de buffer.
It's a kind of buffer which helps the tree not to get to cavitation, for example. You see, because it's a surplus of water which can move to the.
Claro, es como el árbol lo usa como un método adaptativo, digamos, para que no entre en cavitación, o sea, claro, es como un coagulador.
So, well, that means that the tree, even if, for example, the water from the soil is lacking, so at least it can continue photosynthesis during a certain time.
Claro, él necesita balancear muchos procesos, por ejemplo, continuar con el proceso de la fotosíntesis, y eso hace que bueno, que eche mano a diferentes procedimientos, digamos.
Yeah, and also one thing that you know that in any case, so that means even when the soil water is full, okay, so you will still have this contraction and expansion, more or less, but that's still present every day. You will have this.
Claro, dice que aunque haya mucha agua en el suelo o de otra situación, él continúa a hacer esta expansión y contracción, digamos. El árbol es un proceso per se que se da en el árbol.
So if you look in close detail, all along you know, the growing seasons, even when it's raining, you still find this little movement.
Cuando está lloviendo, se produce este movimiento de expansión y de contracción.
¿Ningún factor externo va a influir en su funcionamiento?
Hay una parte, es como una parte que es básica en el comportamiento. Después, en la intensidad de esa expansión, es una parte que es básica, es debido al procedimiento per se, y otra parte que es debido al factor climático. O sea que hay una influencia, pero es parte de la respuesta, digamos. La respuesta del árbol está compuesta por diferentes partes. Una parte es el procedimiento per se, aunque esté lloviendo, aunque esté full en agua, el árbol sigue expandiendo y contrayendo, digamos, y lo que varía cuando hay condiciones de sequía es la intensidad de la respuesta. Y ese diferencial entre lo básico del procedimiento y la intensidad, o sea, la intensidad completa, esa diferencia es debido a los factores externos. Bueno, vos sabés más que yo, pero bueno, trato de explicarlo en lenguaje común.
So this is just to come back to the way to evaluate radial growth, because in several cases we are interested also not only in this water movement, but also in radial growth per self. So we have seen before basically what I explained with the blue lines. So you go from one maximum and you look to the next maximum, and so this represents the next increment. Then, for example, you go to this maximum to that one, so you draw an horizontal line, and the difference here between this line and the peak is another increment, and so on. You see, for example, during this period there's no increment because the peaks are lower than that one, and then you go to the next peak, which is this one. You have a very small increment, and so on. So this is a classical way to measure this radial growth. But there's another system which has been also tested, which is represented by the red line. And the way it is that you start with the highest peak, which is this one, and you draw an horizontal line, and then you move the slope until you find another peak crossing with this line. This is this one. You draw an horizontal line, and then you move it down until you meet the next maximum, which is here. Then again, you move the slope, and you get this red line. Okay, so this is what they call the linear growth. That means, and the hypothesis which is behind is that, and the question which was behind this study was to say, well, in this case, we consider then when we have water shortage, so there's more, no expansion anymore, so there's no growth. At the opposite of this other method, which consider that even during this period of water shortage, so you can still have some growth.
Son dos approaches para simular el crecimiento, digamos, el crecimiento radial. Uno, el que ya habíamos hablado antes, que es el azul, crecimiento cero durante los momentos de déficit de agua. Y el otro es un approach, o sea, que asume un crecimiento lineal, donde va uniendo los máximos, ustedes ven el último máximo, busca con la pendiente hasta alcanzar el máximo anterior. Y así va reconstruyendo el crecimiento de una manera lineal.
So basically that means that you have nearly, with a red line, with this system, you have growth nearly all along the growing season, compared to the blue one, or you have growth only when there's no tree water deficit.
Claro, con la línea roja ustedes es como que sostienen por debajo, o el pensamiento que sostiene eso es que el árbol como está creciendo todo el tiempo. Y con el enfoque cero, el de la línea azul, cero crecimiento, es como que va creciendo de una manera más escalonada, digamos.
So the way you will be estimating also this tree water deficit will be a bit different, because in the first case with the blue line, so this will be the difference between this line and this line, compared to the red one, which will be all this area between this signal and this red line.
Claro, y se van a generar diferencias en el cálculo de déficit de agua, digamos, porque uno supone, uno va a sobreestimar el déficit y otro no.
So this is what is represented here when you have, well, the different types of growth and the different types of tree water deficit calculation.
Claro, ese es bueno, el cálculo del déficit de agua para un enfoque y para el otro, digamos.
So, and in that study, they come up with a conclusion that, yes, indeed, some growth can occur when you have tree water deficit, but it's very small. You see, it's less than 5% of the growth. So we cannot say that there's no growth. There's indeed some growth, but it's very limited.
Claro, dice que no es que no hay crecimiento, pero es muy limitado, es menos del 5% del crecimiento total que se da en los superiores.
And to try to support as well this conclusion, the author of this paper tries to fit this model with I'm sorry, to the water deficit, and see if this model is better than the one with the linear model.
Claro, y ellos concluyeron que hay un mejor fit, digamos, del modelo cero, ese que supone la línea azul, digamos, que el modelo digamos, el modelo lineal, y que ellos, bueno, utilizaron como comparador o algo así el déficit de agua, digamos.
See.
El déficit de
So he used these two different kind of estimates of water deficit, the one corresponding to the blue and the one corresponding to the red, and then he compared that to an estimation of the tree water deficit that he computes here, like the vapor pressure deficit, the water potential of a soil, and some coefficients. And then he compared what he obtained from the dendrometer signal to this estimation of the water deficit.
ellos hicieron una estimación desde el punto de vista fisiológico, digamos, por decirlo de alguna manera, utilizando el potencial, el déficit de presión de vapor y el potencial del suelo. Hicieron unas estimaciones y compararon los resultados del dendrómetro con esos simulados, digamos, o estimados, and the result was.
And the conclusion was that the better link with this estimate of the tree water deficit was indeed coming from the water deficit calculated from the zero growth model.
Fueron los déficits de agua fueron mejores calculados, estimados, los que provenían del crecimiento cero, la línea azul. O sea, ellos son todos argumentos que, digamos, apoyan la utilización de ese approach de cero, crecimiento cero.
So it's what is shown here, but it's very difficult to look at it at that scale. But anyway.
En esa escala es muy difícil ver los gráficos, pero que eso es lo que.
But then he looked at that, and you see that he got correlation with his zero growth model of nearly 0.7 on one of the species, 0.8 with Quercus, and again 0.7 with Pinus. So the link he considered was quite good, and it was mostly connected to the water potential of the soil, and not much to the vapor pressure deficit.
Sí, esos resultados es como, no entendí bien, pero esos resultados es como que estuvieron más conectados al potencial del suelo para esas especies que al potencial al déficit de presión de vapor. En Licea, por ejemplo.
Con la línea esta de crecimiento cero.
With the zero model.
Sí.
Con la línea.
It was the best of the two, and this is the result for this zero with the delta W calculated from vapor pressure deficit and soil water potential. Yeah. So the link is good. Well. Okay, so now just to tell you a bit what we are doing ourselves with these dendrometers. So one of the objectives, for example, in our case, is to compare behavior of different species. And I've just represented here the mean reaction from this dendrometer values for 3 species I'm working with: European larch, Japanese larch, and hybrid larch.
Esto es, bueno, volviendo a sus estudios, digamos, para mostrar el comportamiento entre diferentes casas o diferentes especies y el híbrido. El híbrido con el que él trabaja usa el Larix decidua con el Larix eurolepis. Larix decidua es el europeo que él le llama EL, European larch. Japanese larch es el Carferi,
Yes, this is just to illustrate, because one of the questions that we have with this species is we are working on what is called hybrid vigor or heterosis, which is
nosotros llamamos heterosis o vigor híbrido, y por eso usa la especie madre, la especie padre y el híbrido, el hijo.
so when you go in the field, you can observe after a certain number of years that the hybrid is growing much faster than the parents. But in this kind of study, we want to understand why the hybrid is growing better than the other parents.
Claro, él dice que cuando uno va al campo ve que el híbrido crece más que los parentales, pero con este tipo de estudios lo que se pretende es saber por qué el híbrido crece más o entender mejor esa diferencia.
And for example, not working with radial growth, but with total height, we observe that, for example, the hybrid during one growing season usually has a shorter growing season than the parents, but it has a growth rate which is much faster than the parents.
Dice que en una sesión de crecimiento el híbrido parece tener un periodo de crecimiento mucho menor, pero crece mucho más rápido que los padres.
So,
El crecimiento en altura, por ejemplo, está hablando. Ellos, bueno, es para estudiar estos efectos de vigor híbrido. Cuando uno cruza un buen padre con una buena madre, de estudiar ese efecto del cruzamiento, digamos, de cuánto mejor es la progenie.
¿Y qué buscan ellos? ¿Mejorar el crecimiento, aumentar el crecimiento o crecimiento y calidad de madera?
You are interested only in growth or growth and good quality?
no, the whole thing, yeah, sure. No, the whole thing.
And also he has a criterion for climatic changes. Él también tiene que tener en cuenta el cambio climático, digamos.
Yeah, so what you can observe is that indeed the hybrid is growing faster than the parents, which is the red line, at least at the end of the growing season. So it's faster, especially compared to European larch. Even if at the beginning of the growing season you see that the European and the hybrid are growing nearly the same, and then during summertime things are changing.
Al principio, bueno, el híbrido y el europeo es como que crecen más que el japonés, pero llega un punto en el que el híbrido se despega y crece más que la madre, digamos.
Yeah, it's just an illustration, and you see.
Y el japonés, que es el verde, que crece menos al principio, después en un punto, digamos, como que se une más al híbrido. O sea, crece más. El que menos crece es el europeo. Pero tiene ritmos, lo que él quiere mostrar es que tienen ritmos de crecimiento. Los parentales tienen ritmos de crecimiento diferentes.
And for example, if we make again a focus on what's going on during a cycle, you see that the hybrid is much more sensitive, for example, compared to the European larch. To what?
El híbrido es mucho más sensible que comparado con el europeo.
So this is the kind of information that we are just starting to try to accumulate in terms of growth, but also in the water movement to try to understand, in relation with the climate, what is behind this overgrowth of the hybrid.
Claro, esa es la base, digamos, científica para decir el sobrecrecimiento, para explicar el sobrecrecimiento del híbrido respecto de los parentales. O sea, se nota que el híbrido es como más sensible o más reactivo que los padres. Los ejes, at the X you have
The time.
time,
Yeah.
and this is growth.
Yeah, it's a radial growth. Yeah. Well, it's just to illustrate that you can go deeper and deeper, with this kind of tools and try to get information on not only on growth but also on water movement and what does it mean in relation with environmental factors.
Solo para demostrar que tenemos que ir cada vez más profundo en el entendimiento del crecimiento, digamos.
So it's also not only interesting to look at species level, but it's also interesting to look what's going on at the tree level, for example. So you could compare fast and slow growing trees and see what differ between them, why one is fast and one is slow growing, and what are the consequences, for example, in regards with water availability. For example, are the fast growing trees more sensitive to drought than the slow growing trees or not? The same for dominant compared to dominated, and you can compare many things like that and try to understand why this is fast and what are the consequences to be fast, for example.
Él dice que, o sea, estas comparaciones que nosotros hacemos para híbridos, para parentales, es factible hacerlas para árboles que crecen rápido, árboles que crecen más lento, digamos, y para saber si a lo mejor árboles que crecen más rápido son más sensibles a alguna situación, por ejemplo, de estrés, de falta de agua en el suelo, que otros que crecen menos, pero son más tolerantes, digamos, en algún aspecto a la sequía. O uno también puede trabajar sobre árboles dominantes y dominados para ver cuál es la respuesta de esos árboles y que eso tenga una consecuencia sobre el manejo, digamos, de los árboles. Lo que quiere decir es que no solamente en genética lo podemos aplicar, sino que se pueden aplicar a otras áreas.
Okay, so one thing which is, of course, of very high interest is to link this signal with environmental data. And probably you can do exactly the same as we do with microdensity data. So you can look at correlations between some signal and environmental parameters. And this is just one illustration of, I think, an interesting way to look at some of these links.
Claro, bueno, esto es lo que nos interesa en definitiva es linkear, digamos, el comportamiento del árbol con el ambiente. Es probablemente el mismo criterio que usamos con la microdensidad, de utilizar la correlación entre el ambiente y la microdensidad. Y eso es una ilustración, digamos, de que es posible. La metodología es más o menos, o la idea subyacente es más o menos la misma.
So it's a study by Cocosa in Italy, and so it's more a methodology that he wanted to show. So you have a signal from the dendrometer, which are represented for 3 different species. So from that you get the stem diameter variation in this case, which is represented here, and he puts the, I think it's the maximum temperature, which is represented here. And you see quite closely then when the temperature is very high, so you have the minimum growth. So that's visually you can already see that there's a link between the maximum temperature and the way the tree reacts in terms of growth. So in the methods that he presents, first he starts to normalize the data, both the climatic data and the growth data. So he starts to normalize them, and then he takes the derivative at each bound.
Es para uso de normalización tanto en los parámetros climáticos como en el crecimiento radial, y usa la primera derivada, the first derivative.
First derivative,
la primera
yeah.
derivada. O sea, son metodologías de análisis.
And so he gets this kind of picture, where you have here the time, which is presented here, and you have the derivative, which is represented here. So you know that when you will be at 0, that means that you are at a peak. When you have a negative slope, that means that, for example, temperature is decreasing. When you have a positive slope, that means that temperature is increasing. Okay? So what we can observe here, so he represents the two curves. One is for temperature, which is this one. And the other one represents the radial growth.
Y esa es la negra más gruesa, digamos, es la de la temperatura, y la negra más finita, esa que va más profundo en el primer mínimo, es del crecimiento radial.
And what it shows is that, for example, for temperature, when you have the most negative, the peak at the most negative part of the curve for temperature, you have the highest growth. You have the maximum, you know, the peak of the maximum growth. Okay, so this corresponds to the peak when the temperature is at minimum in one of the cycle, and this is the peak when the growth is at maximum. Okay, and so this technique allows you to show the time delay between an event and the reaction of a tree.
Claro, eso lo que pone en evidencia es el delay de respuesta del árbol a un determinado estímulo, en este caso la temperatura.
Because you have seen that yesterday there has been some attempts to synchronize, for example, microdensity profiles with climatic events. We have seen different techniques to do that, but all these techniques assume that there's perfect synchronization between a climatic event and the reaction of a tree.
Claro.
It's instantaneously, you know, it's a...
Claro, dice que ayer, las técnicas que vimos ayer, todas asumen que el árbol quiere una respuesta instantánea, inmediata, y sabemos que eso no es así. Entonces, esto lo que pone en evidencia es ese retraso en la respuesta por parte del árbol.
Yeah. And so again, you know, when the temperature is at maximum, so the growth is at minimum, and so on. So you can compute all these delays according to the climatic events. So this is a case for olive trees, where this is quite neatly, yeah. And then you have another case for poplar, where you see that the delay is much shorter. It's quite, in that case, it's nearly synchronized. It's
Claro,
very quick.
Es casi sincronizado, digamos, al mismo tiempo.
And I tried on a data set that I have on Larix, and for example, I looked at this period, just here, which is represented here, and this is the radial growth, where you have again the derivative and you have the time. And I put behind that climatic events, like in that case, it's the air humidity.
La humedad, sorry, the red line is...
Air humidity.
La humedad del aire.
Humidad. Okay. And so you see that when you have, for example, here, I have to think always in the good direction. Wait a minute. Each time I have to think about in that case because it's a reverse.
Don't worry, we are trying to think.
Yes.
No, this is normalized. It's not the real value.
Yeah.
It's the real value.
Yeah, sure. Yeah.
The real value.
But the derivative again.
The first derivative.
All is normalized, and then you get the first derivative. Yeah. So let me think.
Es el normalizado, significa que el cero es el máximo.
Yes, that's normal. Okay, so when you have, for example, this point, that means that you are at a minimum of air humidity. you're at the minimum.
En ese cero es el mínimo, ese punto que mostró usted es el mínimo de la humedad relativa.
Because you're in a negative slope, you arrive at 0, so you're really at the minimum, the peak at the minimum, and you're also at the minimum for a growth. So that means very low air humidity leads to very low growth.
Claro.
Okay?
Muy cortas periodos de humedad relativa, o sea, de periodos malos de humedad relativa, también instan a periodos de menor crecimiento.
¿Eso sería como relacionado al DPV?
She said that it is correlated to DPV or a
Oui.
deficit of
Maybe. And the same, I put also temperature now. This is this one. It's a bit difficult to read. But again, when you're on a positive slope, when temperature is maximum, you see that growth is at minimum. Yeah. And so again, you can compute the delay of reaction between one maximum event and one reaction of a tree. Well, this is just an illustration of the potential of this methodology to also to look at how trees are reacting and the speed with which they can react to a climatic event.
Claro, eso es, bueno, es un ejemplo más para poner en relación, digamos, la reacción a los eventos climáticos extremos.
Another representation that I like also is this one. It's from an experiment in Bolivia.
Bolivia, sí.
It's with a it's with a tropical species. No, because in the same study there was it was both in the tropics, but some were in the northern hemisphere and the other one was in the southern hemisphere.
Tienen dos sitios de estudio en el paper. Y uno está en el hemisferio norte a pocos grados, pero en el hemisferio norte, y el otro sitio está en el hemisferio sur. Entonces nos costó, digamos, ubicarnos en, bueno, el que crece, decrece, o sea, una cosa está en el hemisferio norte y otra en el hemisferio sur. O sea, lo
Yeah.
contrario.
So this was a study with Cedrela, and so the authors looked at the proportion of a day which correspond to the different phases of a cycle.
Ese trabajo de qué partes, digamos, corresponden a las diferentes fases en el árbol.
And so you have in the summer in this region it's quite humid compared to the winter where it's dry, and you see that during summertime. And the red line represents temperature. So you see that when temperature is very high, so you have mostly a contraction phase, which is represented by this portion, and then part of the day, nearly less than 20% is. Yeah. And increment. Yeah, so according to the variation of temperature, you know, the proportion of the different phases within the day will change quite dramatically. When the temperature is low, you will find a big part of growth and also of recovery and not much of contraction. But
cuando la temperatura está en un pico, hay mucha contracción y mucho menos crecimiento y recuperación del agua.
yeah, okay. And then during winter, so you see that you have mostly contraction and expansion, but no growth anymore.
Pero bueno, durante el invierno no hay crecimiento.
And it's not because of a temperature, but it's because it's dry.
No es por un efecto de la temperatura, sino por la humedad.
Okay, so these were just some ways to take advantage of this data and try to understand again.
Es una forma de tomar ventaja de la cantidad de datos y de tratar de entender los
Okay. Then there was the case studies, but maybe, I don't know, according to the time, maybe we looked,
Yes, we can
stop here and we'll see.
Okay. Nosotros vamos a cortar 15 minutos y retornamos.